I love Allianz Field. It's been a dream project from the very beginning. We were fortunate enough to be able to be involved from the very early concept designs. And from those early concept designs, when we first started meeting with the architect, they had aspirations to go above and beyond to create a stadium and a piece of architecture that would truly resonate across the design community and across the sporting landscape across the world. I knew that we needed to make sure that we had the right people to be able to deliver that vision. At Walter P. Moore, we have a tremendous amount of talented people. We tapped into our materials group and materials experts in trying to develop new cladding materials. We tapped to our enclosure engineering design expertise for designing fabric and long span fabric structures. We tapped into our sports team in terms of designing a sports stadium economically and efficiently, and all of those teams worked together to create, at the end of the day, an iconic design. Opening day is two of my favorite words. You've started with, a vision of a project, and then you've helped find a way to bring that vision to life. And opening day, you get to share that vision with 30,000 people or 80,000 people, and all of a sudden, what was something that you helped create now is being shared by the masses. It's just incredible to see the synergy of those different groups working together and collaborating with an architect, collaborating with an owner, collaborating with a construction manager, all aimed at this final goal that resonates on an international scale.
Wow, does that video get my blood flowing? Again, I'm Justin Barton, project manager for Walter P. Moore and Allianz Field. I still love Allianz Field. Happy to wear Minnesota United Day on my crest today, and excited to share more with you about the amazing design behind Allianz Field. Quite simply, Allianz Field would not have been possible without structural steel. The owner desired a stadium that would compete against the best international venues all across the world, serving as an iconic piece of art and architecture for both the team and the state. Creating a world-class stadium required innovative uses of structural steel, the development of new materials, and a refined collaboration between design and construction teams. We used a total of 4,500 tons of steel at Allianz Field. Structural steel was the easy choice for both the primary and secondary systems due to a variety of factors, including lack of repetition, open concourses, irregular geometry, complex schedule, and long cantilevers. The project needed a canopy to protect fans from the unpleasant weather for early season and late season games, while leaving the pitch open to the elements and providing fans that open air experience for the beautiful spring, summer, and early fall months in Minnesota. The 145,000 square foot canopy covers approximately 85% of the seats, protecting fans from the elements and simultaneously reflecting the sound back onto the pitch below. Our structural team studied several different canopy truss systems during the early schematic design process. Each of these was then rapidly modeled in 3D, allowing the architect to make a visual comparison when trying to decide between the different schemes. We also looked at the overall shape of the canopy, ultimately settling on a shape that slopes down to the north, building enabled as only structural steel can do, substantially lowering the roof profile, putting a more human scale at the entrance where most of the fans come in. Ultimately, for the main canopy system, we settled on a prop girder system at each frame line. Although this results in a slightly heavier system than a traditional cantilevered steel truss, it creates a much more open, airy structure and results in far fewer pieces to be fabricated and erected, ultimately resulting in a lower cost for the canopy than a traditional steel truss. At the leading or the inner edge of the canopy, the girder tapers down from 36 inches deep to 16 inches deep, matching the purlins going around the stadium, creating a clean, thin profile all the way throughout. As a construction innovation, our project team worked with Merrill Steel, the fabricator, to design, fabricate, ship, and erect these large canopy girders in one single piece. These assemblies came in at over 110 feet long, 18 to 20 feet deep, and 20 to 30 tons. Again, all shop assembled, shop welded, shop fabricated, painted, put on a truck, and shipped to the site. This enabled 2 of these frames to be erected every day, keeping the project ahead of schedule, even during the harsh winter Minnesota months. Additionally, by allowing all of that to be done in the shop, it allowed the paint system to be applied fully in the shop as well, increasing the longevity of the paint and the overall structural steel systems. Allianz Field's signature element is one-of-a-kind facade going around the stadium and the support system behind it. The owner desired, again, an international venue featuring a continuous and distinctive cladding that wrapped around the entire stadium. In addition to the aesthetic goals, cladding also needed to be weather tight to, again, protect fans from the harsh Minnesota weather, but simultaneously be transparent to visually connect fans outside the stadium to the energy generated within the stadium on the pitch, on the field. It had to be strong enough to span the 22 feet between steel support pipes, but flexible enough to form the undulating geometry going around the stadium. Behind that one-of-a-kind cladding is a structural steel backbone for the undulating facade. The curves between fabric savers truly drove the facade design. Thus, they were coined driver lines or driver pipes. Each one of these support lines carries load in two directions from the fabric, both pushing and pulling on it, in addition to the large thermal stresses built up by the extreme Minnesota temperature. Round HSS steel sections were the ideal choice to support the loading and meet the complex geometry requirements. But how was that geometry designed and documented? Great question. Critical innovation was the common data platform shared by the structural and architectural teams. Early during the design process in late 2015, Populous and Walter P. Moore developed an adaptable workflow, again, using this common shared data platform that could be manipulated and pushed into many different other software systems. Populous created the complex geometry in that profile through a series of sine waves that stacked and varied in amplitude and undulation as we moved around the stadium. The loading on the fabric was a direct result of that geometry. So having that shared data platform, we were then able to rapidly convert those driver lines into fabric analysis models. From that, we could then tell which areas of the fabric were overstressed, so which driver lines needed to be adjusted. And then our structural team could adjust some of those driver lines, send that back within that same common platform to Populous for their review from an aesthetic standpoint. This created a true symbiotic relationship of design, analysis, and performance. Establishing this basically equated to having a single model that all parties were accessing, processing, manipulating, and rapidly sharing data, which enabled numerous iterations to take place to the overall geometry. They could both be, that was then used to optimize the overall design aesthetics, cost, and constructability simultaneously. This then ultimately was then this centerline model was pushed to Tekla, as you see at the top. Tekla is the common steel platform that nearly every steel fabricator uses. By doing so, we were able to ensure that the exact precise geometry of this complex undulating facade was fully done and in the model, rather than having to have the fabricator recreate that off of a 2D set of paper drawings. Every steel piece needed to get the complex facade was in that model. The structural steel connections were fully detailed with unique end plate connections to be able to resist both the bending and thermal loads in there, connecting back to the primary columns and the overall structural lateral system and gravity system for the building. Additionally, structural steel pieces were used to connect the cladding back to these main driver pipes. As you can see in this video, even along the length of a single driver pipe, the complex facade spirals ever so slightly along the curvature of the pipe. A series of 4 simple clamping details at the panel joints, at the intermediate driver pipes, at the upper driver pipe, and at the lower driver pipe were used. A series of steel plates, T assemblies were welded to each driver pipe at approximately 18 inches on center, allowing the fabric to be clamped back to that. That same T shape was then mass produced and installed at every point all the way around the stadium. The final result is jaw-dropping. A beautifully exposed structural steel building that provides the strength and complex geometry required to create the iconic facade and dramatic canopy. Allianz Field truly raised the bar for what soccer stadiums and sports facilities in general in North America can be. Structural steel was a critical component in bringing the owner and architect's ambitious vision to reality for the team, its fans, and the surrounding community. Truly appreciate the time to talk to you today. Thank you for taking the time to learn more about Allianz Field. If you have any further questions, please feel free to reach out. Thank you again.